Hello everyone. I'd like to talk about the solution of a midterm number 1. I'll talk about it step by step. And also I'll talk about the grading scale, the partial credits. Okay, so I'm going to start it now. Okay. Okay, this is the math 1D midterm one solutions. Okay, so first problem. Okay, we're given function f(x,y) equal to xy over x squared minus y squared. Okay, we ask you to do two things. So first of all, find the domain and sketch the graph of the domain. So the domain, of course, is all the xy values such that the denominator not equal to 0. Now this is equivalent to so y is not equal to positive negative x. Okay, so if you want to write the domain in the set notation, so we write it like this. So here is x, y, such that y is not equal to negative or positive x. Okay, if we want to draw the graph, okay, then we need to draw the graph like this. Okay, well, because the origin, of course, cannot be in the domain. So this is a y, this is the x. So first of all, we draw y equal to x. That's this line. Okay. And y equal to negative x. So this is y equal to x and y equal to negative x. So that's like this. So this is a y equal to negative x. Okay, so we say y cannot equal to positive x, negative x, and everything else is fine. So we shade the region. Okay, we say everything else is fine. Okay. Of course, we put it like this. Okay. Okay, so that means everything else except on the two lines. Okay, that's the domain. Okay, so that's the graph. Part B, we ask you to find the limit when x, y both goes to 0. Well, let's look at it. First of all, we say along x equal to 0 and let y approach to 0. So this is on the y-axis. Okay, well, points on the y-axis are in the domain. So we say here the limit, we let y goes to 0. And then here is 0 times y over 0 squared minus y squared. Well, numerator equal to 0, so this is equal to 0. Secondly, we say along. How about we say y equal to half x? Well, we cannot let it y equal to x because denominator will equal to 0. And then we let x approach to 0. Now, this is a line pass through the origin. So y equal to half x. We let x goes to 0, but not equal to 0. Then we consider the limit. So we let x approach to 0. And then numerator become x times half x. Denominator is x squared minus parenthesis 1/2 x parenthesis squared. Okay. Now numerator is equal half x squared. Denominator is x squared minus 1/4 x squared equal to 3/4. So 1/2 over 3/4. Okay. So that's, well, if you simplify, it's 2/3. 2/3. Now this is not equal to 0, which means along two different lines, the limits are different. So we say this implies this limit as x, y approach to 0, 0 of f x, y. This limit does not exist. Okay, so this is a problem number 1. Okay, well, let me see. I'm going to just put it this to say here. Well, because this is, say, 20 points. So I'm going to say, well, this is a 3 points. And this is a 5 points. And then I will say this is a 4 points. This is a 4 points. And this is the conclusion, is 4 points. So this is a 20. No, I think I should put it a little bit higher. So this is a 20. 20 points for problem number 1. Now number 2. Problem number 2. Okay. Number 2 is we have, say, z equal to e to x cosine y. And x equal to r plus s, y equal to r minus s. Okay? And then we ask to find the second partial derivative with respect to r first, then s. So we calculate partial z, partial r first. Okay, this is by chain rule. So this is partial z, partial x times partial x, partial r plus partial z, partial y times partial y, partial r, equal to that. Now this is equal to, okay, partial z, partial x, well, calculate derivative with respect to x, this doesn't change, e to the x cosine y. Now, partial x, partial r equal to 1 plus partial z, partial y, e to x with respect to y, this is a negative sine y. And the partial y, partial r again equal to 1. Then we calculate the second derivative of z with respect to r first, then s. So this is equal to partial s of partial z, partial r. Okay, so we use the chain rule. So this is a partial x of partial z, partial r times partial x, partial s. Then partial y, partial z, partial r times partial y partial s, so that's equal to that. That's the chain rule. And then, okay, so we're going to use the first line, well, partial z partial r we already calculated. You calculate dribble with respect to x. So this will equal to e to x cosine y minus e to x sine y, because the calculated derivative with respect to x, nothing changed here. Now partial derivative with respect to partial x partial s, which is 1, and then plus, you calculate derivative with respect to y, here you're going to have e to x negative sine y plus e to x negative cosine y. And then partial y partial s equal to negative 1. So that's like this. Now if you simplify, so you see here we have, whoops. Let me see. Okay. Whoa, what's going on? Okay. Okay. Now, if you look at the last term, negative, negative, positive. Okay, positive. So you have two terms of e to x. This is a 2. Cosine y. You have this one. Now, for the sine part, okay, well, you see the second from last, again, is a negative, negative, positive. And then the second term is a negative cancel out. So that's it. That's this one. But we are asking to find the partial derivative at Rs equal to 0 pi. So we say when, okay, so when, not where. When R equal to 0, S equal to pi. Now you plug it into xy, so x is equal to pi, y equal to negative pi. And then, so this gives us, we say, therefore, second partial with respect to r and then s, evaluate at r s equal to 0 pi is equal to 2 times e to pi and then cosine negative pi. Well, cosine is even function. So cosine negative pi equal to cosine pi, which is a negative 1. So this is equal to negative 2 e to pi. So that's the answer. Okay, so if you look at the partial credits, I would say this is 4 points, and this is 4 points, and then we calculate this simplified 3 points, and then probably this is 3 points. Okay, so we have 14 points here. Okay. Problem number 3. So problem number 3. Number 3, we have f x y z equal to x over y plus y over z. And the point is 4, 2, 1. Okay. So we ask you to find the direction. The function decrease most rapidly, and find the directional derivative in that direction. So here we say, first of all, we find f sub x. at 4, 2, 1. Okay, you calculate drift with respect to x, which is 1 over y, and y is equal to 2, so that's just 1/2. Okay, and then partial drift with respect to y, you have 2 terms, 4, 2, 1. Okay, the first term you're going to have negative x over y squared. Second term you're going to have a 1 over z. Okay, 1 over z equal to 1 is 1. Negative x over y is equal to negative x over y squared. So it's a 4 over 2 squared. Okay, let me put it here. So x equal to 4, y equal to 2 squared. And then here's a plus 1 over 1. Okay, so that's negative 1 plus positive 1 equal to 0. And f sub z is, okay, let me directly put it the points. Okay, so this is a 4, 2, 1. You calculate drift with respect to z, which is equal to negative y over z squared. Negative y over z squared, well, y is 2, z is 1, negative y over z squared is a negative 2, 2 over 1 squared, okay? So that's like this. And then we say, well, the gradient vector f evaluated 4, 2, 1 is equal to, so we have 1/2, 0, negative 2. So that's gradient vector. Now, that's enough now. We said, well, then we say that direction okay, so I just said that direction, which means that direction function decrease most rapidly, which is equal to the opposite direction of a gradient vector, right? Because we say in the gradient vector, function increase most rapidly. In the opposite direction, function decrease most rapidly. Then we say this is equal to negative 1/2, 0, positive 2. And then we say the directional derivative okay, notice I use the directional derivative. That means the directional derivative we're looking for. Okay, then this is equal to negative the magnitude of the, well, you put a negative sign inside of, doesn't matter. Okay, so that's equal to this one. Okay, equal to that. Now, of course, this is equal to negative. Okay, so here when you put this square root of negative 1/2 square plus 0 square plus 2 square. You put it like that. Okay, 1/4 plus 4 is equal to 17/4. So that's equal to negative root 17 over 2. So that's the answer. Okay, so here, well, then I would say, well, this is 14 points again. I would say this one is 6 points, and the gradient vector 2 points. And now I would say this is a 3 points, and this is a 3 points. So this is a 14 points. Okay, so that's problem number 3. Okay. Okay. Problem number 4. Number 4, we say, let me just write a solution. We need to find a point on the cone which is the closest to the point 0, 2, 4. Okay, so we just put it like this. We say, well, we set up the optimization problem. We say we need to minimize well, you need to know which one you're minimizing. Minimize f, x, y, z, okay, equal to. Now, the distance formula has a square root. You see, our textbook talk about a couple of examples. So if you want to minimize or maximize the distance, it's same as minimize and maximize the square of the distance. So that's x minus 0 squared plus y minus 2 squared plus z minus 4 squared. So we minimize this function, and then subject to the constraints. Constraints is the point must be on the cone. So we call this g x, y, z equal to, say, x squared minus y squared minus z squared. Now this is equal to 0. Okay, g must equal to constant. So that's this. Now, by Lagrange method, Lagrange multiplier, we have a gradient vector of f. Okay, gradient vector of f must be proportional to gradient vector of g. Okay, is proportional to gradient vector of g. Okay, now this gives us three equations. Okay, partial f partial x 2x equal to 2 lambda x. Second one with respect to y, 2 times y minus 2 equal to negative 2 lambda y. And then 2 times z minus 4 equal to negative 2 lambda z. Okay, now we have one more equation, is g equal to 0, which is x squared equal to y squared plus z squared. So we have this equation. So we have 4 equations, 4 variables, x, y, z, and lambda. But if you look at the first equation, okay, this first equation, we can say move the right hand side to left hand side, cancel the 2, factor the x, then we have 1 minus lambda equal to 0, which means which implies either x equal to 0 or lambda equal to 1. Okay, now then we look at the 2 cases. We say, first of all, if x equal to 0, okay, then by the last equation, y squared, so y squared plus z squared has to be 0 because the point must be on the cone. Now this implies yz must be 0. Y equal to z equal to 0. Then we have this, so here, then we evaluate this function f at 0, 0, 0 equal to, so 0 squared plus 0 minus 2 squared plus 0 minus 4 squared. 2 squared is 4, negative 4 squared is 16, so it's equal to 20. So that's 1 point, the function value. Okay, we found a point on the cone. Okay, that's the first case. Second case is if lambda equal to 1. Then, if lambda equal to 1, you substitute into the second equation, okay? So you're going to have a y equal to, because substitute second equation, you have 2y minus 4 equal to negative 2y. So negative 2y, you move to the left-hand side as 4y equal to 4. 4y minus 4 equal to 0. So y must be 1. And then the z must be, if you substitute in the third equation, okay, you have 2 times z minus 4 equal to negative 2z. So you have a 2z minus 8 equal to negative 2z. Negative 2z move to left-hand side, 4z equal to 8. Z equal to 2. Z equal to 2. Now, if this is the case, then we say x, okay, is equal to, well, x squared equal to y squared plus z squared. So it's the square root of positive negative 1 square plus 2 square is a 5. So that's equal to that. Okay? And then, well, this implies we evaluate at positive and negative root 5. That's x, 1, 2. Now this will give us the same value because the function is positive and negative root 5 squared plus y is a 1, okay? Y is a 1. 1 minus 2 squared plus 2 minus 4 squared. That's equal to, well, root 5 squared is a 5. 1 squared is a 1, 2 squared is a 4, so that's equal to 10. Now you see, of course, we say, therefore, points positive and negative root 5, 1, 2. On this cone, x squared equal to y squared plus z squared are closest to point 0, 2, 4. Okay, so this is use a Lagrange multiply method. You don't have to do any further testing. Okay, so this is a, now let's see if I give a this is a 20 points. So this part is set up we call this f objective function, and a constraints. Okay, constraints. And then, well, I think I'm going to put it here is this part, you find the 2 possibilities, 2 points, and then here I'm going to put 4 points for the other equations. And then I will say this is 3 points. And this part I will say is 4 points. And let me see how many now. We have, let me see, here is 8, 12, 15, 19. Yeah, I think already 19, so this is just 1 point for the conclusion. Okay, so this is 20. So that's problem number 4. Okay, number 5. Number 5. Okay, we put a solution. Now, the integration, from the integration, we know the region. Okay, first of all, you write down the region. So this is x, y. Okay, now x change from 0 to 4. So 0 to 4. So this is from given integration. Now y change from root x to 2. Now here, once you write this, we should be able to draw the graph. So here, let's see. if we draw the graph like this, okay, draw the graph. You say x change from 0 to 4, so here is a 1, 2, 3, 4. Y change from root x to 2. So we said this is suppose this is 1, 2. Now y equal to root x means x equal to y squared. So that means this point. Okay, so we're going to have this curve. Okay, so we say this curve is y equal to root x. So this is a 4 origin. So 1, 2, 3. 1, 2. Now from this curve to y equal to 2, y equal to 2 is a horizontal line. So this is a y equal to 2. This is a y, this is a x. So we say, well, that's the region D. Okay, if I write a D here, so that's the region D. Now, if you want to reverse the order, then we say, we write this as x, y. Now you see, this time y change from 0 to 2. 0 to 2. X, okay, from 0 to, well, this means x equal to y squared. So that means x change from 0 to y squared. Okay, once we write this, then we say the integration. So here is 0 to 4, root x to 2. Here is a 1 over y to the third plus 1. dy dx. Now this one is hard to evaluate, so that's why we switch the order. Reverse order says 0 to 2, and then 0 to y squared. Then we have the integrand that doesn't change, and then here's a dx dy. Okay, and now this is equal to, okay, so here we say 0 to 2. With respect to x, this is a constant, 1 over y to the third plus 1. Now x plug in y squared, 0, so that's just a y squared dy, right? Now if you do a substitution, okay, do a substitution, so here this is 0 to 2. How about I'll do this, and then you see here is a 1 over y to the third plus 1. 1/3 d y third plus 1. Well, this is we call it implicit substitution. You can let u equal to y to the third plus 1, or just do this. You see, so 1 over u du, the antiderivative is equal to log absolute value of y to the third plus 1, and then you plug into 0. Okay, when you plug in 2, okay, so that's 2 to the third is equal to 8 plus 1 is 9. So this is 1/3 log 9. When you plug in 0, log 1 equal to 0. So this is a problem number 5. Okay, number 5, if you look at the partial credits, I would say I will give 3 points for this one, and then 3 points for the region. And now we say, well, change the order, 2 points, and then say here, evaluate 4 points. So total is 12 points. Okay, then let's see, problem number 6. Okay, so first of all, we are giving two curves. Okay, so one of the curve you see x squared plus y squared equal to 2y. Okay, so this we can do complete and square, move the 2y to the left hand side as a y squared plus 2y. You plus 1 both sides. Y squared plus 2y plus y squared minus 2y plus 1, which is equal to y minus 1 squared, equal to 1. You add 1 both sides. Okay, now we have, let's draw the graph. Okay, let's draw the region. Okay, so here, well, we said in the first quadrant, right? In the first quadrant, okay. Now, the first equation is x squared plus y squared equal to 4, or x squared plus y squared equal to 2 squared. So the radius is a 2. So how about we say this is a 1, 2. And here is a 1, 2. Okay, so we have a quarter circle. Quarter circle like that. So we said this one is x squared plus y squared equal to 2 squared. Okay, like that. The second one, of course, the center is at here, at the 0, 1. Radius is a 1. Okay, so here we have something like this. Okay. Something like that. Yeah, I think so we say, well, this one, yeah, maybe the first one, let me see, the first one, let me make it a little bit better, hopefully. Okay, and then we say this one is, we say x squared plus y squared equal to 2y. That's this one. Okay, now if we write as the polar equation, we know this one is r equal to 2. And then this one, well, that's a standard equation, r equal to 2 times sine theta. So you see when theta equal to 0 is 0, start from here. And then theta equal to pi over 2. So this is the pi over 2. And then sine equal to 1. 2 times 1 is 2. Okay. Now, we say between those two curves and in the first quadrant. So that's this one. Okay. Okay. So that's the region. 1. So here is a 1. Here is a 2. Okay. Yeah. Okay. So that's like this. So then we say we can describe the region using polar coordinates. Polar coordinates are theta. Now you see theta is between 0 and pi over 2. And then r is between 2 sine theta and 2. Okay, so we have that. Now once we describe that, then so we can integrate this easily with use a polar coordinate, say d, x, d, a. So this is equal to 0 to pi over 2, 2 sine theta to 2. And then the integrand is x equal to r cosine theta. Now dA is equal to r dr d theta, remember? Dr d theta. So this is equal to integral from 0 to pi over 2. Now, with respect to r, cosine is like a constant. We move out cosine. r squared, the antiderivative is 1/3 r to the third, and plug in 2 sine theta. So we can put a parenthesis around here, and then d theta. Okay, so when you plug in 2 to the third is 8. Both term has 8, so 8/3 move out. And then here is 0 to pi over 2. And then the first term, you already put out 1/3, so that's 1 times cosine theta is cosine theta. Second term is cosine theta. Let me see. Okay, second term is cosine theta, and then sine third theta, okay, d theta. Okay, now this is easy to integrate. You integrate term by term. The first term, cosine theta, the antiderivative is sine theta. Plug in pi over 2, 0. Second term, say here, minus, well, if I put one more step, well, if you cannot see, I can see the next step. This is third theta d sine theta. Okay, again, it's an implicit substitution. Okay, so this is equal to 1/3, and then 1 minus, and this one is equal to 1/4. Okay, sine fourth theta plug in pi over 2, 0. So that's just equal to 1/4. Okay, let me put it this is sine fourth theta plug in pi over 2, 0, right? If you want. So 1, that's equal to 1. So this is equal to 1/3. 1 minus 1/4, which is a 3/4. Okay, 3 cancel the 3, 4 cancel the 8 is a 2. Okay, so that's I write it in the pretty much detail. Okay, so here let's see. I'm gonna say this 5 points, and this is 5 points because that's the important step. And then I'm going to say, well, everything, once you write that, this is, say here, I'm going to say you set up this 5 points, and the evaluation is not that bad, 5 points. Okay, so that's 20 points. Okay, so that's roughly speaking. And then okay, that's the solution of the midterm. Okay, when you watch it, please watch step by step and make sure you understand each step. Okay, yeah, I think that if you carefully look at the review, well, our problems pretty much match the review type of problem. I hope everybody did well, like the first quiz. People did very well. So I hope this time again you do very well. Okay, well, I haven't started grading yet, and then I'm going to try to finish grading as soon as possible. Now I have more than 100, close to 150 people, and then each one person has 2 pages. Well, people write more than 2 pages. I wrote each exam. Okay, I wrote 2 pages, and then the space I leave there. If you write it not too big, and then the space is enough. So say if you think about it, each person has 2 pages. There's about 300 pages, more than 300 pages. Okay, so I'll see. probably I'm gonna spend it the next week most of the time grading. Okay, so I'll talk to you next time. Okay, bye bye.